In our next class, we have to discuss about the elevation in boiling point. Actually, I was given 4 colligative properties, and the first one is relative lowering of vapor pressure, and in that I was given Raoult's law. What exactly Raoult's law I was given? And Raoult's law is applicable only for dilute solutions as well as ideal solutions. What exactly ideal solutions, I'll tell you later. Got it? So now our next colligative property, second colligative property among 4 is elevation in boiling point. In that name only you have elevation. Elevation means what? Increased. Delta T you can write. Delta T. B. B means boiling point. Delta TB. What exactly boiling point first of all? Afterwards we can discuss what about elevation and boiling point. What exactly a boiling point means? The temperature at which vapor pressure of a liquid is equal to atmospheric pressure. I repeat, boiling point is nothing but the temperature at which vapor pressure of a liquid is equal to atmospheric pressure. Means while you are heating, some pressure will be applied. Vapor pressure, I told you, those vapors apply some pressure on surface. That particular pressure should be equal to atmospheric pressure. Everybody knows atmospheric pressure 180 m. Okay, so boiling point means you have idea. What exactly elevation in boiling point? When boiling point will elevate? Elevate means increase. When a non-volatile solute was added for a particular solvent, I was added non-volatile solute. Suddenly what happens? They have macro particles. Macro particles means big. As I told you, they occupy surface. You are heating. You cannot heat properly. Means it takes time. Suppose take normal water and NaCl water. Means salt water. Both you heat. Normal water heat fast because that is a pure solvent. Salt water if you heat, it takes time because it consists of non-volatile NaCl particles which are macro. Macro means big particles. So they cannot vaporize fast. Certainly what happens if a solution consists of non-volatile solute, boiling point will increase. That increase in boiling point is called elevation in boiling point. Suppose I will give you example with the simple one. Boiling point of water, suppose, is T naught. Naught means solvent, remember this? Naught means solvent. Okay. Boiling point of NaCl solution. NaCl in water otherwise. In water. It is Ts. Now my question, which is big? T naught is big or Ts is big? Ts is big than T naught because this NaCl is a non-volatile solute. They are macro in size, means big in size. So if you are heating, they occupy surface, they cannot enter into vapor phase. Certain number of vapors will decrease. So boiling point will increase because more temperature is required to heat this. Suddenly this Ts will be more. Therefore T naught is less than T naught. Sorry, Ts. T naught is less than Ts. Boiling point of solution is more than boiling point of pure solvent. So what will be the elevation? Elevation in boiling point is Ts minus T naught. This will be the elevation in boiling point. Sir, why Ts minus T naught? Why not T naught minus Ts? Which is big, I told you. Ts is big. Certainly Ts minus T naught only we have to take. So what exactly the elevation in boiling point delta TB? Delta TB is equals to Ts minus. It's a very important. Delta TB is equals to Ts minus T naught. So what we discussed in this particular elevation in boiling point. What is that elevation in boiling point? The increase in boiling point of whom? Solution which consists of non-volatile solute, because non-volatile solute consists of macro in size. Macro means big in size. So delta TB is equals to Ts minus T naught we have to take, because boiling point of solution is elevated. Elevated means what? Increased. So boiling point of NaCl solution was more than boiling point of water, pure water. Boiling point difference you can take as delta TB. Elevation in boiling point. Elevated means increased. So delta TB is equals to Ts minus T naught. So just like in previous, relative lowering of vapor pressure, I was related with the mole fraction. Afterwards, I was given relation with the molarity. In the same manner, here also this elevation in boiling point we have to relate with molarity. Let's see how to give that relation. Okay, now let's see the relation between this elevation in boiling point as well as molarity. To have that, I was given a small graph here. Here on x-axis I am taking the boiling point, and here I am taking a vapor pressure. Vapor pressure on y-axis I am considering, and boiling points I am considering on x-axis. So very clear, as a temperature increasing here, boiling point is increasing. Here this is the graph for solvent, and this is the graph for solution 1, and this is the graph for solution 2. And here I am considering vapor pressure. So this is the graph between vapor pressure versus boiling points. Very clear, as the temperature increasing, vapor molecules will increase, so vaporization increases. But here one thing is very important, which is big. Vapor pressure of solvent is big than vapor pressure of solution, as we know already. There we are taking P0 minus Ps, lowering of vapor pressure. When the solution having a non-volatile solute, vapor pressure decrease, means P0 is big than PS1. PS1 is big than PS2. If solution 1 is less concentrated than solution 2. It is very important. I am considering the concentrations like this. That solvent is less concentrated than solution 1. Solution 1 is less concentrated than a solution 2. Got it? So I am taking a graph between vapor pressure and boiling point. So concentration of a solvent is very less, so vapor pressure is very high. Certainly here vapor pressure's relation is like this. P0 is greater than, PS1 is greater than PS2. S1 means solution 1, S2 means solution 2. Boiling points order is like this. T0 is less than Ts or T1 I written. Okay, T1 not a problem. T1 is less than T2. Because solution 2 is more concentrated. As I told you, non-volatile solute is more in this. certainly more temperature is required. So T2 is big. So it's very clear. Vapor pressure P0 is more. Boiling point T2 is more. Got it? So if you observe this as well as A, B, C as one triangle like this, A, B, C, D, A, B, D1 and A, C, some F, A, B, C, D, E otherwise. So you can take this is one A, B, D1 triangle and A, C, E1 triangle. Consider those. Consider triangle A, B, D and triangle A, C, E. Two triangles we are considering. So how you can have a relation now? Now A, B by A, B by A, C is equals to A, B by A, B I can consider. But otherwise A, C by your choice. Okay, A, B by A, C. What is A, B? Means T1 minus T0. A, C means what? A, C is T2 minus T0. A, D means it is P0 minus PS1. A, E is nothing but P0 minus PS. This I am considering now like this. A, B means difference between these two. T1 minus T0. Why T1? Because T1 is more than T0. T1 minus T0. Because boiling point of solution is always more. Vapor pressure of solvent is always more. These two things you must know. Okay, so T1 minus T0 by T2 minus T0 is equals to P0 minus PS by P0 minus PS2. The same you can write like this now. How? This is a delta T1 by this is delta T2 is equals to delta P1 by delta P2. See how I written? This is the change in temperature. This is called elevation in boiling point, delta T1, and this is elevation in boiling point between solvent to solution to like that. Okay, so delta T1 by delta T2. Delta P1 is the lowering in vapor pressure, delta P, and this is delta P2. It's the lowering of vapor pressure. From this, what you can say therefore? T1 by T2 is equals to P1 by P2. So both are directly proportional. So therefore you can write delta T1 is directly proportional to delta P1. Otherwise simply you can say this is elevation in boiling point. So delta TB is directly proportional to delta P. Got it clearly? So elevation in boiling point means increase in boiling point. Increase how? When the non-volatile solute was added, the boiling point will increase. Why increase? Non-volatile solute means non-volatile solute cannot be vaporized. So boiling points will increase for solutions if concentration increase. Vapor pressure will decrease. Those I am taking one relation here. Here delta T and delta P relation I got by considering two triangles from ABD and AC. I am considering like AB. You know maths clearly already. So AB by AC. AB means T0 minus T1 or T1 minus T0. T1 minus T0 because T1 is big. T1 minus T0 by T2 minus T0. Same way AD means P0 minus PS1. AE P0 minus PS2. You can take the relation. Therefore, delta TB is proportional to delta P. Got it? Just have a look and I will continue the relation because I am going to give you the relation. Elevation in boiling point, I am giving relation with some concentration term like molality I am giving. Got it? So let's see now how to have a relation. Just remember this. I'll continue with this. Delta TB is proportional to delta P. Just have a look at that and remember both. Delta TB is proportional to delta P, because you know what exactly delta P. That's why I am telling you, remember that particular portion. Just analyze this and you just have a look at this. Delta TB is proportional to delta P. Okay? Looking at that or not? Got it? Have a look at this. Delta TB is proportional to delta P. I will continue with this. You have to take notes also properly, one by one, all these things. Now I will continue with the same. Delta TB is proportional to delta P. Now let's see the relation. What's the relation now? Delta TB is equal to some proportionality constant K into delta P. This you remember? From Raoult's law. From Raoult's law. We know everyone. What is that? Delta P by P naught is equals to molality by 1000 into W. W is the gram molecular weight of solvent. So in place of delta P, if P naught bringing here, the entire term we can substitute here. What exactly delta P now? Delta P is equals to M by 1000 into W into P naught. Got it? See, in place of delta P, if I substitute all these things here, 1000 constant, weight of solvent for a particular solution, gram molecular weight of solvent is constant, and P naught is constant. Vapor pressure of pure solvent is always constant. So this is constant, this is constant, this is constant. So therefore I can write delta P is equals to some constant K dash into molarity. These I am all removing. 1000, W and P naught, they are constants for a particular solvent. P naught is a constant. For a particular solvent like water, gram molecular weight is 18 for water, 1000 constant. So you can substitute this delta P here. Now you can have delta TB relation. So this delta TB is equals to some K into K dash into molality. Okay, so now this you can write, it's very important. This delta TB you can write as some KB into M. This formula is more important than this. This is delta TB relation with molality. So how I was derived? I was taken a graph between vapor pressure and boiling point, and I got this relation. Delta TB is proportional to delta P. Very clear? Delta TB is the elevation in boiling point and K into delta P. K is a proportionality constant. Delta P I was substituted by using Raoult's law. Everybody knows delta P by P naught is equals to M by 1000 into W. Why I used B? Boiling point, elevation in boiling point. That's it. There is no much reason for it. Okay, delta TB is equals to KB into M. So delta P by P naught I am writing as M by 1000 into W. So delta P is equals to M by 1000 into W into P naught. So 1000 constant, W constant, P naught constant. I was written delta P as K dash into M. So delta TB I got KB into M. And KB is called molar elevation constant. Molar elevation constant. Otherwise you will ask me, what is this building? Kb is molar elevation constant. Correct? So Kb I was written elevation constant. Otherwise you can write as a helioscopic constant. Molar elevation constant, or simply elevation increased. Okay. So Kb also has one important formula we will have in thermodynamics also. Kb is equals to RT naught square by 1000 into Lv. This is the important relation Kb. R means you know everyone is a gas constant, and T naught we know that boiling point of a pure solvent, and Lv is latent heat of vaporization. Latent heat of vaporization. Latent heat of vaporization, that is Lv. So finally we got one important relation. Delta Tb is equals to Kb into m. Have a look at this. Delta Tb is equals to Kb into m. So Kb is a elevation constant. Kb values for solving numericals they will provide mostly. Otherwise for water and for acetic acid like that they are constant. I'll give you later while solving numericals. Got it? So this is about elevation in boiling point. What is delta Tb? Everybody have idea. What exactly delta Tb? I'm just repeating. Delta Tb is equals to Ts minus T naught. This you remember. Oh, don't continue with afterwards this. No. Delta Tb I am giving relation. Ts minus T naught. What is delta Tb? Ts minus T naught. Got it? Just have a look along with me. Got it? So if you understand this elevation in boiling point, which is very clear, depression in freezing point is the next. Got it? Okay. So depression in freezing point is very simple if you understand this. Okay. How to have this depression in freezing point means only one thing. Only one thing. Delta Tb means Ts minus T naught you are taking. But for depression in freezing point, ulta you take, that's it. That is T naught minus Ts you take, enough. Remaining everything will be same. Instead of B, you will have F. F means freezing. Here you have elevation in boiling point. Boiling point will elevate, but freezing point will decrease. Correct? So how to have that depression in freezing point? Let's see. Once again, I'm telling you, just have a look at this and this and this. Enough. You can say units for kV everything. So delta Tb means it's Kelvin, and the molarity units, you know, mole per kg. If you write here m value, so delta Tb by m, so that you will have what is the units per kV. Helioscopic constant or molar elevation constant. That's it. kV values they will provide for solving numericals. Got it? And this is also applicable for ideal solution only. Sir, you are saying ideal solution, but you are not giving what exactly ideal solution means. Very simple. Ideal solution means the solution in which solute cannot undergo further dissociation or association. There is no dissociation, there is no association. That is called ideal solution. So which are ideal? Very simple. If the solute is most covalent, non-polar, sugar is ideal. NaCl, it will dissociate as Na plus and Cl minus. Sugar solution, ideal. NaCl solution, non-ideal solution. That is important difference between ideal and non-ideal solutions. and it is applicable only for ideal solutions. Which is applicable? This particular all colligative properties applicable for ideal solutions only. Correct? Our next thing is depression in freezing point. Same story. I won't draw any graph. If you look at our textbook, you can understand, because what exactly the difference I was given between elevation in boiling point and depression in freezing point. Of course, I'll explain what is freezing point. Freezing point of solute is more, or freezing point of solvent is more, or solution is more. Everything I'll explain here. What exactly freezing point? Very simple. What exactly boiling point? The temperature at which vapor pressure of liquid is equals to atmospheric pressure, that is boiling point. But here that much not required. Freezing point means where it freezes. The temperature at which freezing starts. Freezing means what? Freezing. Freeze means make sound. Got it? So freezing happen when the solute particles are very big. Solute particles are macro. Then freezing will be easy. So freezing point of solution is less. Freezing point of solution is less. Boiling point of solution is high. This is the most important difference. Freezing point of solution will decrease, because freezing means coming close. When they can coming close? When they are having macro particles. Macro means what? Big particles. So depression in freezing point, to understand what is the freezing point, I was telling. The particular temperature at which freezing starts. Suppose freezing point of solvent I am taking is a T0. Freezing point of solution I am taking as Ts. Now my question, which is big? T0 big or Ts big? T0 is greater than Ts. So it's very clear. Boiling point means Ts is big. Freezing point means T0 is big. That is only the difference. Freezing point of solvent is T0. Freezing point of solution is Ts. T0 is greater than Ts. Why T0 is greater? I told you already. If the solution consists a non-volatile solute, certainly they are coming close easily, so that freezing easy, because non-volatile solute is present in a solution, then freezing will be easy. Means freezing takes place at low temperature itself. So therefore, what you can write? Depression in freezing point, this is delta Tf. There delta Tb I was given for the previous one. Now this is delta Tf. Therefore, what exactly delta Tf now? This is T0 minus Ts. Don't get confused. Why you are using this much of time in numericals instead of T0 minus Ts? Ts minus T0 if you use, that option also they will provide in NEET exam or any competitive exams. Both options they will provide. Suppose answer is minus 3.1, they will give plus 3.1 also. So it should be very, very clear, crystal clear. T0 big or Ts big. For freezing point, T0 only big, because freezing when easy? When the non-volatile solute is present. Certainly solutions can freeze easy than normal solvent. Do one thing. You are at home now. Keep one beaker of normal water and NaCl water, both you keep in fridge. Which will freeze you can say now. Salt water can freeze easily than normal water. So freezing will be easy for solutions which consist of non-volatile solute. Very clear. Got it? So freezing point of solution is less. Boiling point of solution is high. So what is delta TF? It is T0 minus Ts. That's it. Got it? So one thing over. So next is delta TF is equals to same Kf into M. That's it. So same story. There delta TB is equals to Kb into M. Here delta TF is equals to Kf into M. Okay. What is delta TF? I was given already T0 minus Ts. So same formula I can write like this. T0 minus Ts is equals to Kf into M. What exactly M? Everybody knows. That is molality. And what is Kf? Kf is there. What I said, Kb, molar elevation constant. Here molar depression constant. Molar depression constant. Molar depression constant Kf, or cryoscopic constant. It is also fixed for particular solvent. For water, Kf value is there 1.86 like that. Okay, so Kf values they will provide in solving numericals. What is Kf? Molar depression constant or cryoscopic constant. And next one, similar way, Kf you have, that is RT naught square by 1000 into LF. Very simple. LV I was written for kV. For Kf I am writing LF. Latent heat of freezing. Latent heat of freezing. LF means same latent heat of freezing. That's it. So we have three colligative properties. Now, one is relative lowering of vapor pressure, elevation in boiling point, and a third one now depression in freezing point. Last one is osmotic pressure. That's very simple because osmotic relation is just like ideal gas equation. What is ideal gas equation? PV is equals to nRT. For osmotic pressure, the same gas laws we will use for write pi V is equals to nRT or NST, or pi is equals to CST. Like that we use some formulas. I will tell you, don't worry. Okay, so we discussed three colligative properties. All three colligative properties finally I will write here. Okay, what are the three colligative properties we discussed? Alright, so one by one I will write. First one we discussed P0 minus Ps by P0 is equals to number of moles of solute by number of moles of solute plus number of moles of solvent. For dilute solutions, this number of moles of solute is negligible, and I was given for molarity relation, go through that. And the second one, delta Tb is equals to Ts minus T0 is equals to Kb into molarity. Okay, and third one, delta Tf is equals to T0 minus Ts. Just have a look. Okay, so delta Tf is equals to T0 minus Ts and is equals to Kf into molarity. That's it. And all these three applicable for dilute solutions as well as ideal solutions. One more we have osmotic pressure, I'll tell you, and these are applicable for ideal solutions only. These are for ideal solutions only. Got it? 3 colligative properties we discussed. For dilute solutions means n solute is negligible, I am telling you. For delta dV means Ts minus T naught I told you. I am not saying by head. Ts by the guy told you. Boiling is difficult for solution. That's why boiling point of solution is high. Freezing will be easy for solution. So freezing point is low for solution. So delta Tf is equals to T naught minus Ts. So what is T naught and S? You have difference. Naught means solvent. T naught is the boiling point of solvent. This means here boiling point of solution. Here Ts means freezing point of solution. Thank you. Just go through these 3 colligative properties over. Thank you.